This project is located in the coastal area of Fujian. The site was originally a harbor tidal flat and later became cultivated land and partially a pond. The building under construction is building number 16 of the community, with 23 floors above ground and 1 floor underground. This building has a height of
102 meters,
and the structure is in the form of a shear wall. The foundation form is a pile cap foundation with a cap thickness of 1.5 meters. The pile cap supported by pre-stressed concrete pipe piles with a design pile diameter of 500 millimeters. The design effective pile length is approximately 11 meters to 30 meters. The bearing layer at the pile end is the strongly weathered granular granite layer. Monitoring shows that settlement occurred after the main building was completed. As of June 25, 2021, the cumulative maximum settlement of the building reached 106 millimeters, and the southward horizontal displacement of the top of the building is approximately 22.8 centimeters. The inclination rate is 3.6 per mil, which is beyond the specification standard of 2.5 per mil. As a result, reinforcement and corrective measures are required to keep the inclination within the acceptable range as per the specifications. Hengxiang Hongye was entrusted by the owner to handle the settlement and inclination of the building. After on-site investigation and analysis, the main causes of uneven settlement are as follows. 1. The pile end was not embedded in the bedrock layer according to the design requirements. 2. There is a weak formation composed of thick silt with low bearing capacity. 3. Significant differences in elevation exist in the top plate of the bedrock weathering layer. The geographical structure is different, and the stress on the piles is uneven. Equal pile length has great influence on bearing capacity, which causes sinking. In order to solve the problem of continuous settlement of buildings, it is necessary to reinforce the soil around the pile and the bearing layer at the pile end, and correct the deviation of the building so that the tilt of the building is controlled within the allowable limits specified in the regulations. The specific restoration plan is divided into 2 steps. First, the soil around the pile is reinforced, and then deep reinforcement and lifting are performed. Step 1. Soil reinforcement around the pile. This step is merely to reinforce the soil around the pile and below the foundation cap, so that the soil around the pile is closely cemented with the pipe pile, and the piles are tightly cemented to form an overall composite foundation. Improve the holding force of the soil around the pile on the pile and the strength of this area, so that the overall force is uniform. It prevents the building from further sinking and cracking and other hidden dangers, and better ensures the subsequent lifting effect. When the pressure value reaches 1.5 megapascal, it indicates that the foundation in this area has been strengthened. Step 2. Retrograde lifting in deep soil. After the first stage is compacted, the pile continues to drill down to a depth of no less than 1.5 meters into the strongly weathered granular granite layer. Through the layering back, the strongly weathered granite soil layer is reinforced and compacted, effectively improving the bearing capacity of the formation. Driven by pressure, the grout enters soil layer to form grout bubbles and spreads around. As the consolidation of the grout and soil progresses, the volume of the grout soil composite gradually increases, and the internal pressure of the grout rises. At this stage, the vertical force begins to manifest, and the lifting effect becomes gradually significant. Since the lower soil layer is dense, the soil does not settle. With the continuous injection of grout, an upward lifting force is formed under pressure. When expected lifting signs appear at the monitoring points, appropriate adjustments in pressure, the grout ratio, and the injection rate are made to achieve a gradual and uniform lifting of the foundation, and finally meet the target flatness requirements. The implementation is carried out according to the on-site remeasurement value. During the lifting process, multiple devices are cyclically operated, and the parts with large subsidence values are lifted sequentially to the parts with small subsidence values. Due to the soil layer compaction effect, the building is lifted slowly. The maximum lifting per hour does not exceed 2 mm, and the maximum lifting per day does not exceed 10 mm. This allows for precise control and flexible lifting while ensuring the structure remains undamaged. At this stage, the hole locations are arranged according to the building structure and foundation form. The outdoor holes are arranged corresponding to the shear wall with incline drilling. The indoor holes are arranged symmetrically on both sides of each cap with vertical drilling. The hole diameter is between 10 mm. During this process, an intelligent monitoring system is used to dynamically monitor the lifting situation in real time, providing data support to the site, and achieving the visualization of building lifting and intelligent data monitoring. Compared to traditional techniques, our minimally invasive approach is gentler. The overall process does not affect the building structure and the seismic performance, and does not disturb the soil layer of the foundation. Gentle lifting is achieved, and a better lifting effect is also obtained. The injected special grout material is inorganic material, which can solidify within 1 to 30 seconds. The diffusion range can be controlled within a radius of 2.5 meters. After a 20-day construction period, the inclination rate has been reduced from 3.6 per mil to 0.3 per mil, and the effective lifting and tilting correction of the building was finally achieved.